We're going to find the equation of a polynomial. I think you'll recognize this polynomial. It's a quadratic, a parabola. So if I wanted to find the actual equation of this, I think you've done this last year actually. I would start by finding the roots of this equation, or the zeros. It crosses the x-axis at 3, it looks like, and at -2. So I could say those are the zeros of this equation. So in other words, you can also think of those as the solutions, right? Where this equation equals 0. So far, so good? Now, could I go backwards? If I know the solutions, or the zeros, or the roots, could I find the actual equation? Well, sure we could. We could figure out what factors produce these. So a factor that would produce this would be x plus 2. A factor that would produce a 3 would be x minus 3. Now, if I want to find the actual function, I'm going to set this equal to y. So, is this the equation of my quadratic? I'm going to have Mr. Haas throw this in Graphmatica as we speak. If you could kindly do a drum roll back at home.
Okay, what am I typing in here? X plus 2.
X plus 2 times the quantity x minus 3.
X minus 3, got it.
Drum roll, please. Here we go, ladies and gentlemen. Oh my gosh. Can you see that? It's a little faint, but that's certainly not the function that I have graphed here. But wait, it goes through the right roots, but what's wrong? You're right. It's a little more stretched out than ours. You know, now that I think about it, there might be a coefficient here. There's going to be some number, k, that's going to determine how stretched out this function is. Could I actually find this k? Could I find what that constant is? I bet I can. Why don't you get rid of that offensive, wrong function, Mr. Haas? And let's go back to our original function here. So we can use a tried and true strategy, and that is pick a coordinate, pick a point, the xy values we can then plug in to solve for k. I can pick any point that I want on the parabola, except for the roots, and if you want to know why, try it and you'll see what happens. So let's pick a handy point. I think I'm going to pick the y-intercept right here. So let's see, that's 0, -3. Just a random point, but a handy one. So let's plug the 0 in for x and the -3 in for y and see what we get. So I've got y, -3, equals k. That's what I want to find out. X is 0. That's kind of handy. All right, let's do a little algebra. We've got 2 times -3 is -6 times k. I want to get k by itself. Voila! K is 1/2. So that seems to suggest that I multiply by 1/2. Mr. Haas, will you do me the honors? Will you put in 1/2 times x plus 2 times x minus 3? There it is. Look, we were successful. So let's just back up and see how we did this. We found the roots. We used those roots to find the factors. We knew that we would be multiplying it by some constant k to see how stretched out that parabola would be. Plug in a point, a handy point, can be the y-intercept or any other handy point on the parabola to find k. And there you have it. Now if I wanted to, I could double distribute and simplify and everything, but we don't really need to do that. We can leave this as our equation. All right, let's try a cubic. Mr. Haas, do you want to try a cubic?
I'd love to.
Excellent. Here we go.
So let me see if I can do one of this stupid. Is that okay?
Are you imitating me, young man?
No. So, first I'm going to find the zeros. I'm going to find the roots. This one looks like -2, so I have x equals -2. This one looks like 0, and this one is at x equals +1. So those are my zeros. That's where it crosses the x-axis. Therefore, the factors must be, and I'll put them on the side here, x plus 2, because if I fill in a negative 2, I get 0. What's this one going to be? I guess just x, because if I put in a 0, it is in fact 0. And the last one must be x minus 1. So that's basically my equation. Do you want to try it, Ms. Stewart, and see if that works out?
I do. Okay. Here we go. Are you ready?
I'm ready.
Boom!
What the? What? Oh, that's right. This equation must have gotten stretched by some factor. And I know you're thinking you could probably look at my original one. Oh, wait a minute. Which was my original one? Oh, this was my original one? Oh, this was my original one. I forget which one was my original one.
The bigger one is the original one.
The bigger one is the original one. Oh, the one that you sketched looks like it was like scrunched. So my original one must somehow have been stretched out by something, and it kind of looks like it was stretched out by 2. But let's see if we can actually find that value. So we're missing, and I'm going to clear away some of this stuff. I want to know how stretched out it was. So now what's the deal? I have to pick some point that is not on the x-axis. This looks like a reasonable point. Any point that crosses my grid, I guess, is fair to use. So I'm going to pick the point -1, oops, -1, 4. That's my xy point. I'll put in a 4 for y, so I have 4 is equal to k. I'm putting in -1 for my x's. -1 plus 2 is 1. -1 for this x. -1 minus 1 is -2. So if I multiply these all together, that's -1 times -2 is 2. Divide by 2, and k must be equal to 2. I hope you're going to try this again, Ms. Stewart.
I'm going to try.
All right, so let's see if that is in fact the right equation.
Very exciting. Boom!
I guess it came out right on top of the original one, so that must be the correct equation. Now, of course, as Ms. Stewart said, you're not used to writing equations in factored form like this. I mean, I could multiply all this out. It would kind of be a pain, but I could multiply all it out, and you would get some nice polynomial, which you're used to seeing. But this is a perfectly legitimate equation to put in your graphing calculator and come out just like that.